Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this Olympiad math equation. So we have a to the power of 3 plus a squared is equal to 80. And we want to find the value of a. So our solution. So we start with, obviously, a to the power of 3 plus a squared is equal to 80. And now what I'm going to do is I want to get all these terms on one side. So I'm going to move 80 to the left-hand side by subtracting 80 on both sides. So now I have a to the power of 3 plus a squared minus 80 is equal to 0. Now 80, this is the same thing as, negative 80, this is the same thing as negative 64 minus 16. So I'm going to rewrite this as a to the power of 3 plus a squared minus 64 minus 16 is equal to 0. Now I'm going to individually factor these out. So a to the power of 3 negative 64, I'm going to move these together. So now I have a to the power of 3 minus 64 plus a squared minus 16 is equal to 0. Now, 64, this is the same thing as 4 to the power of 3. And I'm changing it to 4 to the power of 3 because, as you can see, we have a to the power of 3, so it's better to change this into something cubed. So now I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 16 is equal to 0. Now, a squared, I want to change 16, so it's something to the power of 2. Well, 16, this is equal to 4 to the power of 2. So now I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 4 squared is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus 2ab plus b squared. So in this case, a is a and b is 4. So a to the power of 3 minus 4 to the power of 3, this is going to equal a minus b, so a minus 4 times a squared plus 2a times 4 plus b squared, so 4 squared. Now we can go ahead and simplify this a little bit. This would equal a minus 4 times a squared plus 2 times 4, that is equal to 8. Oops, sorry, it looks like I made a mistake. This is not 2ab, this is simply just ab. So, just going to be 4a plus 4 squared, this is 16. So now, I have a minus 4 times a squared plus 4a plus 16 plus a squared minus 4 squared, and this is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a minus b times a plus b. So in this case, a is equal to a and b is equal to 4. So a squared minus 4 squared, this would equal a minus 4 times a plus 4. So now I have a minus 4 times a squared plus 4a plus 16 plus a minus 4 times a plus 4 is equal to 0. Now, as you see, both the terms have a minus 4. So I'm going to factor out a minus 4. And if I do that, I get a minus 4 times a squared plus 4a plus 16 plus a plus 4 is equal to 0. Now over here, I can go ahead and combine like terms. 4 and a are like terms, and 16 and 4 are like terms. So now I have a minus 4 times 4a plus a is 5a, so I have a squared plus 5a plus 16 plus 4 is 20. And this is equal to 0. Now I have two equations. I have a minus 4 is equal to 0, and I also have a squared plus 5a plus 20 is equal to 0. For a minus 4 equals 0, all I have to do is I can simply add 4 on both sides, so then these two cancel out, and I will be left with a is equal to 4. Now for a squared plus 5a plus 20 equals 0, I'm going to be using the quadratic formula negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is equal to 1, b is equal to 5, and c is equal to 20. So now this would give me negative 5 plus or minus the square root of, just normal 5 squared minus 4 times 1 times 20 all over 2a, so 2 times 1. Now this is equal to negative 5 plus or minus the square root of 25 minus 80 all over 2 times 1 is 2. Now this is equal to negative 5 plus or minus the square root of negative 55 over 2. Now, the square root of negative 55, this can be written as the square root of 55 times I. And I, this is equal to the square root of negative 1. So I have this over 2, and this is another, or 2 more solutions to this problem. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stay until the end of the video, where I have a bonus problem that is similar to this one, which you guys can try to solve. Alright, so we have 2 to the power of 20 minus 9. Now 2 to the power of 20, this is the same thing as 2 to the power of 10 squared. Because if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. And in this case, 2 to the power of 20, that's the same thing as 2 to the power of 10 times 2. So this is equal to 2 to the power of 10 to the power of 2. So I have 2 to the power of 10 to the power of 2 minus 9. This is the same thing as 3 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10, and b is equal to 3. So now I have 2 to the power of 10 plus 3 times 2 to the power of 10 minus 3. Now 2 to the power of 5, this is equal to 32. 2 to the power of 6, this is going to be equal to double of 2 to the power of 5, which is going to be 64. 2 to the power of 7, this is going to be double of 64, which is going to be 128. 2 to the power of 8, this is going to be double of 128, which is going to be 256. 2 to the power of 9, this is going to be double of 256, which is going to be 512. And finally 2 to the power of 10, this is going to be double of 512, which is going to be 1024. So now that we have our value of 2 to the power of 10, I add 2 to the power of 10 plus 3 times 2 to the power of 10 minus 3. 2 to the power of 10 is 1024, so I have 1024 plus 3 times 1024 minus 3. Now 1024 plus 3, this is equal to 1027, times 1024 minus 3, this is equal to 1021. Now 1027, this is equal to 1000 plus 27, and 1021, this is equal to 1000 plus 21. So now if I substitute these values in, I get 1000 plus 27 times 1000 plus 21. Now to solve this, I have to first distribute, so let me distribute the 1000s. So I have 1000 times 1000 plus 1000 times 21. Now I have this plus, now I'm going to distribute the 27. 27 times 1000 plus 27 times 21. Alright, so now 1000 times 1000, this is going to be, well, 1 times 1 is 1, plus 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. Plus, now 1000 times 21, that's going to be 21,000, plus 27 times 1000, that's going to be 27,000, plus finally 27 times 21. We can go ahead and do that here. 27 times 21, 7 times 1 is 7, 1 times 2 is 2, add our 0, 2 times 7 is 14, we're going to carry the 1, 2 times 2 is 4, 4 plus 1 is 5, so I have 27 plus 5, 40, 7 plus 0 is 7, 2 plus 4 is 6, and we have our 5, so I have 567. So now I have 1 million plus 21,000 plus 27,000 plus 567. Now 21,000 plus 27,000, that is going to be 48,000 plus 567. 48,000 plus 567 is going to be 48,567. And finally, 1 million plus 48,567 is going to be 1,048,567. So this is our answer. Alright, so first off, 2 to the power of 18. This is equal to 2 to the power of 17 plus 1. So now I have 2 to the power of 17 plus 1 minus 2 to the power of 17. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, a is equal to 2, m is equal to 17, and n is equal to 1. So now I have 2 to the power of 17 times 2 to the power of 1 minus 2 to the power of 17. Now from here, I can go ahead and factor out 2 to the power of 17. So now I have 2 to the power of 17 times 2 to the power of 17 times 2 divided by 2 to the power of 17 simply just 2 to the power of 1, minus 2 to the power of 17 divided by 2 to the power of 17 is simply 1. Now 2 minus 1 is going to be 1, so now I have 2 to the power of 17 times 1, which is equal to 2 to the power of 17. Now, to simplify 2 to the power of 17, well, if I have something in the form, a to the power of m plus n, this is equal to a to the power of m times a to the power of n, right? And 2 to the power of 17, this is equal to 2 to the power of 9 plus 8. So this would equal 2 to the power of 9 times 2 to the power of 8. Now, 2 to the power of 9, this is equal to 2 to the power of 4 plus 5, which is equal to 2 to the power of 4 times 2 to the power of 5. So 2 to the power of 4, this is 16, times 2 to the power of 5, this is 32. So now I have 16 times 32 times 2 to the power of 8, this is equal to 2 to the power of 4 plus 4, which is equal to 2 to the power of 4 times 2 to the power of 4, which is equal to 16 times 16. So I have this times 16 times 16. Now, 16 times 16, this is 256, times 32 times 16. We do this right here. 2 times 6 is 12. 6 times 3 is 18. 18 plus 1 is 19. We got our 0. 1 times 2 is 2. And 1 times 3 is 3. So if I add these, 2 plus 0 is 2. 9 plus 2 is 11. 3 plus 1 plus 1 is 5. So I have 512. So I have 256 times 512. Now 256 is the same as 200 plus 56. And 512 is the same as 500 plus 12. So now I can solve this by distributing. First, I distribute the 200, so I have 200 times 500 plus 200 times 12 plus distribute the 56. 56 times 500 plus 56 times 12. Now 200 times 500, that's going to be 10 with 4 zeros, plus 200 times 12, that's going to be 24 with 2 zeros, plus 56 times 5, that is going to be 280 with 2 zeros, plus 56 times 12, that is going to be 112 plus 560, which is, let me do this right here so you guys can see, 672. Now to add these up, first off, 2400 plus 28,000, that is going to be 30,400, plus we still have, now 100,000 plus 30,400 is 130,400 plus 672, and this is going to be 131,072. So that is our answer.